The common oxygen concentrators are molecular sieves oxygen concentrator. They are physical oxygen production. The principle is separating and storing the oxygen from the air through a series of processes such as filtration, compression, and adsorption. We know the content of nitrogen is 78% in the air and the oxygen is about 21%. The two which account for the 99% of the air. The oxygen concentrators mainly use the molecular sieves and adopt the pressure-swing adsorption technology to absorb the nitrogen and obtain the oxygen with the purity level around 90 to 95%. When the oxygen concentrator is working, firstly it filters the impurity, dust, and other impurities from the air to make the air clean, and then press the air by compressor and flow into the oxygen system. We also call it the sieves barrels, well filled with the molecular sieves. Molecular sieves are zeroth porous material with a large surface area, and its adsorption capacity for the nitrogen and the oxygen are quite different. When the compressed air enters the sieves barrels, the macrospores on the surface of the molecular sieves will absorb a large amount of nitrogen and let the unabsorbed oxygen pass through. Then the oxygen will stop in the oxygen tank and flow to the oxygen outlet. The adsorption of the molecular sieves for the nitrogen is related to pressure. When pressurized, the nitrogen will be absorbed, and when depressurized, the nitrogen will be released and discharged into the air. It allows the molecular sieves to regain its capacity to absorb the nitrogen for recycling. Usually, the oxygen concentrators have two sieves barrels, and each will work alternatively to separate the oxygen and store oxygen in a faster way.